All right, now we're back. We did a little spiel on how to turn in the homework and capture screenshots and all that, and hopefully that was helpful. But back in our coding engine now, we're going to be moving on to lab number 2. So what I recommend that you do is in your file menu here, go ahead and create a new file. And let's just call this mod1 lab 2. Makes sense to me. .py. I hit save. We're going to put it in the same folder, which is our module 1 labs folder. Go ahead and create file. And now we have a blank coding file to work with. I will at least momentarily zoom in a click or two here, Visual Studio Code, so you can see what I'm doing. And now I'm going to bounce back over to the course so we can get the instructions for lab number 2. Oops, sorry, not the correct one. Here it is. Okay, strike 3. There we go. Lab number 2. So with this lab, we're going to start venturing into what is really important in any programming language, really, is the capability to do math. And I'm going to try to do this as quickly as I can. So we might get some spillover from this first module into next week, by the way. All right. So we are going to use the input method again, and they are pointing us back here. So just kind of an example again. All right, getting input from the user, converting the input from a string to an integer. So this is something we haven't done yet. So like when we get a value from the keyboard, and this is a really important concept, you guys, anything that's typed at the keyboard that a user is entering comes in as text, even if it's a number. This is really critically important, right? So if I'm prompted for my age, I might type in the number 35, but in reality, it's not coming in as a number. It's coming in as a string of characters, a 3 and a 5. I can't do math with it, in other words. So this is really kind of an important concept. So we have this function that we use that allows us to take anything inside the parentheses. This is called the int function, that converts whatever's inside the parentheses to an integer if it's possible for that to happen. In this case, they're converting a floating point number into an integer. So when it outputs, watch what happens. It drops the 0.5 and just makes it a 3. You would think it'd go up to 4, but that's not how it works. Okay. The other thing that I could do is if this was, let's say, a string, and I'm typing here. Let's say we put in, 34 as a string, and I'm converting that to an integer. That will take that series of characters and actually turn it into the number. Now, when it goes back to the screen, by the way, it's converted back to a string. So one of the secret sauces of the print function is that it takes whatever is thrown in there and turns it back to a string to go to the screen. So whatever we grab from the screen and whatever we put on the screen is in the form of text, always, right? If we need to process it as a number so we can do math, we can do that. And I'm going to do a really basic demonstration here. And so, for example, I might have y, which, I don't need to convert always, right? So I can do, like, for example, I can just make y an integer like this, right? I'm actually putting a number into y. And then if I want, I can come up with another variable called z, which would be x plus y. And then I can just output z and see what it is. So let's run that and see the result here. So if this works, this number has success, or this string has successfully been converted to an integer, stored in x. This integer was stored in y. We added the two together, which equals 79. We stored it in z, and then we output z. Z gets converted back to text to go to the screen and give us the right answer. That's kind of the process of it, right? So sometimes when we're working with users and we're asked them, hey, how old are you? I'm 29 forever, or whatever, right? To do math with that number, we have to convert it to an integer. So that's kind of where we're starting here. So the first instruction, I'm trying to find my browser. There we go. Let's go back. That's not the right browser. That's the right browser. All right. So that was the example of that. We also have a little demonstration on how to do F strings. And guess what? We've been doing that all along. All right. So I don't think we need to demonstrate that at the moment. We'll demonstrate it on the fly. And then we're going to look real quickly at the mathematical operators that are allowed in this language. Okay. So, all right. For those of you that hate math, take a breath. You'll be okay. Right. Because I know that's a thing. Right. And I was never really a super huge fan of math when I was younger. And then when I got into computer science and I realized, oh my God, computer science is all about math. I started to go into a panic, really, right? Because then I had to go to like a 4-year school. And by the time I finished my master's degree, I had taken like 3 levels of calculus and had enough math credits to teach math professionally, you know, because that's how computer science is. What I will tell you is if you're not good with math, don't freak out. The formulas that we will code with will always be provided or will always be easy to find on the internet. So for example, if I just do a Google search and type, you know, volume of a cylinder, for example, well, Google's just going to tell me what the formula is. I don't have to memorize anything. And not only that, but I can drop in some numbers here and get the result to verify that I wrote my code correctly. And if you look really carefully here, it shows you how it operates. I can just copy it and put it in my code. Not a straight copy paste, but almost, right? The point is, as a coder, you don't necessarily have to be a mathematician. The skill you really have to have is how do I convert that math formula into code that will work, right? And more importantly, once I do that conversion, how do I verify it's correct? Here's one example of how to verify it's correct. Another thing would be just using a calculator or pencil and paper, if you prefer, or a spreadsheet to do the math for you to verify that the code that you wrote is giving you the right answer. And I'll try to demonstrate all that stuff, but right now we need to kind of press forward. So the mathematical operators that we use, and one of them I already did on that little exercise before, are the standard ones. So we have addition and subtraction, the plus and minus keys. We have multiplication and division, right? And if you're new to coding, this might be new to you. So on a computer system, the asterisk key or the shift of the number 8 is what we use for a multiply sign. The forward slash or the same key as the question mark, right by your right shift key on your keyboard typically, that forward slash is for division. Okay, now we get to the weird ones, right? First 4, I mean, everybody kind of gets those: add, subtract, multiply, divide. I mean, you learned those as a kid. Maybe you didn't, whatever, but at least you kind of have heard of them before. It's these other ones that get a little weird. The first one is the modulus operator, which is the percent sign. And what the percent sign does is it's basically division, but instead of giving you the precise amount that something goes into something, it is instead giving you what is the remainder. So for example, if I divide 2 into 2, what's my remainder? 0, right? If I divide 2 into 3, my remainder is 1. I'm not interested that 2 went into 3 once. I'm interested in what the remainder was, right? So this has a very special place. It might not really make sense why you would use it. This was actually developed to make change originally. Somebody, you know, came up with this novel thought, you know, hey, we need remainder math, and they came up with modulus. So we call this mod or modulus or remainder division. Most often you'll hear a programmer calling it mod. So we'll say X mod Y. Okay. The other one is exponents, and exponents typically in most programming language are not expressed through declarations like this. There's only one other language I can think of where they allow exponents directly declared, and that's Visual Basic, where they use the caret symbol, which is the shift of the number 6. In Python, we do two multiplication symbols together. So we would read this as x to the y power, right? So x star star y, y is an exponent of x. The other one is what we call floor division, which is kind of the inverse of what modulus does. Modulus gives us the remainder. Floor division gives us how many times this goes into that and ignores the remainder. Both of those can be important, right? So that one is 2 forward slashes. All right, so those are the basic operators, and we're going to learn how to apply them now, one at a time. So, and I'm trying to get my stuff loaded up in the other screen here. And of course it's locking up, so that's okay. All right, so here's what we're going to do in this exercise. We're going to try to mimic this, right? And I'm going to do this very incrementally here. And the first thing I'm going to do is I'm going to prompt the user for a whole number twice. We're going to store it. All right, and then we're going to do all these other steps. Now, here's what I'm going to do, and I'm just telling you this from a practical standpoint. This is done in a very sequential format. I don't want you to get overburdened with trying to read all of this and then do all the tasks at once. Your brain will not allow you, right? The way to solve a programming problem, another really key thing to think about here, is to do it in bits and pieces, and you start with the simplest things first and build up. Do we know how basically to prompt the user for a whole number twice? I think so. Let's try this. All right, so let's go back to Visual Studio Code. We have our labs already created, and if you want to put like your name at the top, do it. You want to put the date at the top, just do it. You see, I'm not doing it. I'm being snarky about it, and that's okay. So let's prompt the user for 2 whole numbers. And I'm going to say this, prompt the user for 2 whole numbers. So we'll do this. Now, when we grab those numbers, we want to store them. You know what? X and Y come from algebra. They're variables, right? Let's just use X and Y to store them. So I'm going to develop a variable called X, and I'm going to prompt the user with input, and inside there, double quotes, and I'm going to say, please enter an integer, right? And if they don't know what that is, you can tell them whole, counting, number, like 1, 2, 3, 4, 5, like what you learned when you were a kid, right? Now, the problem with this approach is they might not type that. They might type a string, right? Or they might type 3.5. So we need to take that input, all of this, and put it inside an integer function, which converts it to an integer directly after they enter it, and then we store it. Okay, that's one way to do it. Here's another way to do it. I could allow them to just go ahead and enter another integer. So I'll say, please enter another integer. And this will capture it as a string. And then in the next step, I can say y equals int y. So I can convert it after the fact. Either approach is valid. What would a real programmer do? The first approach, probably, because it's more concise. Sometimes, because of the nature of the code you're working with, you don't have that opportunity for whatever reason. So you can do it in the aftermath. So there's the capture. All right. So am I making my prompt read just like this? please enter a whole number value for A. Okay, so he's using A and B, and I'm using X and Y. So I guess I could change. So we can make this A, we can make this B, oops, A, B, B, and B. This is just to follow the instructions, basically. From there, we're going to store both of those values. So we have accomplished the first two tasks, right? Then it says reassign A to be an integer of its string value and reassign B to be an integer of its string value. Well, guess what? We already did that too, right? Using two different approaches. One is the do it all at once approach. The second time we did it with store it and then convert it. Okay. Use F strings for output. So what it's saying here is A is 3 and B is 2. So let's see if we can just create that. Okay. So I'm going to go back here and then I'm going to do a print. I'm going to use the F string approach and I'm going to say A is A, whatever we stored, and B is B, whatever we stored. Right. We have enough to try to run this at this point, so we may as well do it, right? So here goes the run. And it says, please enter an integer or whole counting number. I'm just going to put in 1. Enter another integer, 2. And there it is. A is 1 and B is 2. Seems to have worked. So we grabbed it, put it back up on the screen. Hopefully everybody's okay. Next instruction. Output the following using A for the first operand and B for the second operand. So in other words, we're going to add them, subtract them, multiply, divide, modulus, exponent, and floor. We're going to do all of it. Every single little bit, right? So let's get those pieces in place. And then we're going to, basically display that back on the screen. So I'm going to be kind of strategic here, right? So what I'm going to do is I'm going to do the math and I'm going to store it, or I'm going to do the math and directly output it. You can do it either way. This is what's so weird about this. The bottom line is, which approach are you trying to do and why, right? Okay, so let me show you what I mean by this. So I'm going to do a little comment here and say, do the math for all the operations. Thomas, I just saw your little note, so I'm sorry I didn't do it before. He asked me to zoom in a little bit. All right, so let's do the math, right? So one approach would be, I could just do a print statement and then just print A plus B. But really what they want us to say is, with an F string here, the sum, actually, I think we do it like this, sum colon, and then we would output A plus B. Okay, I want to see if this even works. Let's try it, right? And this is kind of another little tip here. As you're adding stuff to your program, don't like type like 10 pages of code and then hit run and see if it works, right? Did one action. I'm like, did this work? Oh yeah, hey, look, it worked. Right. So there's an example of doing the sum, and you could do all of them like this, by the way, or I could do something weird like this. I could say difference and make it a variable to store it, and then take A minus B. Now remember, whatever's on the right side of that equal sign assignment operator gets evaluated and gets stored in the item on the left. And then I would just output, I would say print, once again with an F string, and I would say difference colon space, curly brackets, difference. All right, let's run that too. Does that work? There you go. So I'm just using 1 and 2 because there's numbers on the keyboard. So the sum is 3. And is the difference -1? Yeah, if I subtract B from A, I get a -1. Right. Now, whichever approach you prefer, you can use a combination of the two approaches. I'm just showing you both. And I'm happy with either one that you use. And I think for the sake of speed, at least for me, what I would prefer to do is this approach where I just say, well, next would be the product, which is multiplication. And I'm just going to brute force do it. I'm just going to say A times B. And then I'll do a print F. What do they call it when you divide? So I'm struggling for the words here. Quotient.
Could you scroll up just a little bit? Here, like that.
Right. And so here we'll do A divide by B. And now I'm getting a little braver because I think it's going to work, right? So I'm doing a bunch of these at once. And then we'll do print F, oops, double quotes. And I'm sorry about those autocomplete boxes, you guys. They get in the way often. And once again, I'm looking for the words here. Maybe I should pull this off to the other screen. So the next one is remainder. Put mod in parentheses, by the way, so you guys know which one that is. And then we're just going to do a %sign B or mod. The other thing I do want to point out is I'm kind of eliminating the spaces here on these, but most programmers, for the sense of being able to read it better, usually put spaces around their operators, right? And what I'm showing you is functionally it doesn't matter. Do print again, F, right, and I'm going to get that panel to disappear. And then we're going to do a power, or, exponent, if you will. And then that would be A star B. And then we're going to do the last one, which is going to be the, I don't know what to call it aside from floor quotient, no remainder. And then for that one, we'll just do a double / B. I'm going to run these, and then in principle, I should check them. And I'm going to use really simple numbers on purpose because those are easy to check, right? You see my thinking? I don't want to like throw in like some astronomically huge number here. So here comes the run in the console. Please enter an integer. So I'm going to put in, this time I'm going to do 4 and 2. And I'm doing that on purpose, by the way. So, all right, so we put in 4 and 2. A is 4 and B is 2. The sum is 6. The difference is 2. The product is 8. The quotient is 2. All correct. This is interesting. Why is this one a floating point number? Okay, we'll talk about that. The remainder is 0. So how many times does 2 go into 4? Twice. What's left over? Nothing. So that's correct. Mod is 0. The power, if I take 4 to the second power, that's 4 squared, or 16. And the quotient would be 2. How many times does it go in with no remainder? Twice. So all of those are working. All right. The next part of this exercise is kind of an interesting one. I'm going to move the instructions back over so you can see this, and I'm going to try to not obscure the code so you guys can keep copying. But here they're actually having us throw parentheses into the equations for a reason, and it's really all about what we call the order of operations. Now I'm going to pause the recording here for just a second. All right. So I just realized I was paused there again. I just want to show the output of the last little bit for lab 2, just in case. I'm not sure how long I was paused here, so I apologize. But here are the equations from the bottom of the module lab 2, and the respective answers. If you're hurrying to try to catch up, we're going to give you guys a handy tip. That snipping tool that you're using to capture your code, you can also use it to capture the Zoom screen, by the way, while I'm in progress, right? I don't want you turning that in as your own code, but if I go a little too fast, that's one way you can catch up. The other way is you can let go and wait till I publish it tomorrow and you can look at the videos. That's another way. All right. Excuse me. Try to hit this pause button on that, but
Bless you.
happen. So my sneezes on the internet, and I'm spreading COVID all over virtual space. Kidding. All right. Let's move on to the last lab. I'm going to come up to the file menu, create a new file again, and we'll just call this module 1 lab 3.py. We'll put it ideally in the same folder. Now, for those of you that are working on this at home, remember, screenshot your code, screenshot the output, drop it into Word, drop in some words, label it, whatever, and then create a new file. Let's look at the instructions for the next lab. I'm just going to pull the browser up on the screen here. And move on. And I'm hoping we can get through all this tonight. If we don't, we'll pick it up next week and I will adjust the due date. I'm just saying that up front. Okay, so don't get into panic mode about it. So with this one, it says we're going to practice using and formatting fractional data. And now, just from the standpoint of talking about numbers, we're talking about numbers with decimal places, right? Which are, we call it fractional data, or we call it floating point values, because really a fraction can be expressed as a decimal and a decimal can be expressed as a fraction, right? That's what we call fractional. But basically we mean non-counting numbers. So I could express the number 1 as a fractional value of 1.0, or 1.5 as a fractional value of 1.5. You guys see my meaning, right? And I'm not here to really teach you math, but you just got to take it on faith. If you don't know math, just flow with it, basically. So the goal here really is to practice turning formulas into expressions, because that's really what our homework is about. And very, very often as a programmer, and I say this from experience, you won't necessarily be tasked with, hey man, you got to come up with this formula that solves, the world financial crisis. No. Some engineer or accountant or actuary or something will give you that formula. Your job is to convert that formula into what the programming language understands so that it executes correctly, right? So you're writing a piece of software that does that math accordingly. All right. So let's look at the requirements here. It says, find the percentage of a number. Get 2 inputs from a user, an initial value, and a percentage, all right? Calculate and output the percentage of the initial value as a decimal to the 100ths position. So this is a combination of different things going on here. Here's what I want to do, and I know this is kind of an awkward time to do it. I'm going to take a really quick little break, and I'm talking like a 2-minute break, and I'll be right back. So pausing the video. All right, so we're going to resume here and try to get this done. We do have, I think, just enough time to finish it. And I realize that this is a little bit deep, so I don't want you guys to freak out to the math of it, but I'm going to do this in a really systematic fashion. The grand goal, you can see the output screen down here. I'm going to just zoom in on that so you can read it. Basically, what we're going to do is we're going to create an application that takes a dollar amount and finds the compounding interest rate. So in other words, if I put in $10,000 at an annual interest rate of 3.875, how many times is the interest applied per year? 12, right? So 12 months in a year. And how many years elapse before you get that $10,000 to become 13,000, right? Okay, whatever. So follow along with me here. I'm going to kind of do this in sort of a copy paste fashion, just for the interest of speed. So I'm going to provide you first with a couple of notes, and then we'll do all the prompts, right? Now, the first part is to find a percentage of a number. Like, how do you find a percentage of a number? Well, pretty easy. You take a number and you divide it by another number. If it's a percentage, the first number is going to be less than the second number, you know, within a range. In other words, if I'm looking at what is 2 as a percentage of 5, right? I would take the 2 and divide it by 5, and that would give me the answer. So let me just do that really quickly in code so you see what I mean. So if I take, say, x equals 2 and y equals 5, and then I create a new value called z, which is equal to x divide by 5, and then print z, what do I come up with? So I'm just going to run this to show you the result, and the answer is 0.4. So in other words, if I divide 2 by 5, it gives me the result of 40%. So 2 is 40% of 5. Right? That's how percentages work. Typically, percentages are between 0 and 100, or 0 and 1, right? And we express them as a fraction in hundredths following the decimal point, right? So that's kind of like what a percentage is. Now, what I'm going to do here, and I'm going to put this all in the chat. Okay, so this is just to save you guys on typing, right? So I'm going to drop this into my code at the top, so you guys have like a point of reference on this, right? And so we are going to be asked to do compounding interest, right? And this is not something I would just say, hey man, come up with a formula for compounding interest, you know, and you'd be like searching the internet and then sweating bullets, and, you know, maybe you get hives and hide in the corner because you don't do the math. You know, I'm just kind of putting it out there. But this is the kind of thing that happens with programming. Sometimes the information is provided. So what we're going to put in here is we're going to show basically accrued interest as a capital letter A. The formula for that is this, right? And NT is technically an exponent. So I would actually probably do this with it, right? And it just show it's an exponent. So the accrued amount basically will be the principal added with the interest. So we'll have a principal amount we start with. We have a rate that we will declare, and the number of compounding periods in unit of time, right? And then how long that time is in decimal years. For example, 6 months is calculated as 0.5 years because it's half a year. If I was to do 3 months, it would be 0.25 years. Okay. Right, so this is kind of our operating paradigm, and I'm providing it for you. So the first thing I'm going to do is I'm going to grab, and I'm doing this in a copy paste fashion in the interest of time, remember, not because I wouldn't normally code it manually. First, we're going to get the first value. So we're going to ask for the principal from the user. So enter the principal amount. How much money are they putting in? Right. That's going to be stored. How is this going to be stored? It's going to be stored as a string, right? So I'm not doing any conversion here. Right, so we're just going to go with that. But as we converted before a string to an integer, we can also convert a string to a floating point number. This is the command, which gives us fractional value. So if somebody types 10, this will turn it into 10.0. Why do that? Okay, the reason is a fractional or a floating point value will give you higher precision when you do calculations, right? And if somebody's earning interest, you don't want to be gypped out of any pennies. You want to get all of those pennies, every little bit, right? So that's why it's important. Very typically, whenever we're dealing with money, rates, or anything like that, we're usually doing floating point values. That's kind of a given for doing financial calculations. All right. Now we're going to prompt the user and we're going to do a little bit of conversion. So here comes another copy paste. Right? So now we're going to have them enter the interest rate. The interest rate is stored, and then we're going to take that rate, convert it once again to a floating point number, and divide by 100. But notice 100.0. Why? For precision. We will add another variable. I will give you a little more screen space here to work with. And our compounding period will be 12, meaning we compound for 12 months. So we compound 12 times in the course of a year. This is really actually kind of an interesting thing when you get into like money, like, and this is a game that credit card companies play, right? Like, if you put money in the bank, they'll only add interest once a month. If you owe money on a credit card, they'll add interest every day. This is really kind of a really dastardly thing, right? If only they did it, they should give me interest every day and only compound the interest on my credit card once a month. That would be a lot more fair, right? But the banks always do things in their favor, by the way. All right. Now we're going to prompt the user for the time. So in other words, enter the number of years you want to compound this money. We grab it from the keyboard. They're going to type like 10 or something like that. And we're converting it once again to a floating point number, again, for precision. I'm going to scroll here. Now I know you guys are like frantically typing, and then you realize, you take a breath, and he's going to put it in the chat. Right. I'm going to have some other tools I share with you guys. I have some really cool code sharing tools, by the way, that I use. I don't always do this. I really do prefer to manually do it, but in the interest of time, that's okay. Now we're going to take that formula that we were given way up at the top. You guys remember this formula? And really it should be star. And now we're going to convert it into computer code, but in the spots in the formula, we're going to put in our variable names. First, I'm going to come up with a variable called accrued, right? That's where the total is going to end up. And then here's the cryptic looking formula converted into Python. This. Now, this is a really important example, by the way, if you're not picking up on it, because our homework assignment is a mortgage calculator, which has a very, very similar kind of formula in it, and a similar type of conversion. That's why. Okay. All right. So this is all we need to do. This is the entirety of the program, except for the output. So now we're just going to do, and I will say here, output the results. Spell it right though. And here is my output, and we're going to throw in a fresh wrinkle here, and I'm not really spending a lot of time on this, but in the form of output here, we are using the string interpolation, or the F string approach. But you'll notice I added a little something at the end here, which we put in, and actually it's 4 characters, right? So we take the value of accrued, that's dropped in here. And then these characters, this colon indicates we're using a formatting command. And .2f says we're going to put in a decimal point, and then 2 characters following the decimal point, which is a floating point number, and we're going to round it to those 2 decimal points. Why? Because that's how money is expressed, right? Okay. So let's go ahead and run this and see if we get the same results. So when Patrick put this together, he put in these numbers. So I'm going to use these same numbers to run the program. I'm pulling them over to the other screen so I know what they are. And I'm going to type in the same values. All right, here comes the run. I will scroll so you can still see stuff. Enter the principal amount. I'm going to type in 10,000. Then we're going to type in the interest rate of 3.875. Enter the number of years, or okay, number of times the interest is applied per year. Oh, we missed one, didn't we? Okay. All right, that's incorrect. I missed it. I missed the thing, so I apologize. And I'm going back to my solution here to look at this. This is what you get when you go too fast. Yeah, I'm missing a piece here. You know what? I am looking at the time though, and I'm at the point where I don't have enough time to fix it. But let's just call this accurate, even though it's not. I'm missing one additional piece. And I'm trying to see if I can, because the formula is missing it. All right, I'm just going to call it a typo. So guess what, folks? We'll call this the solution. Right, so I just don't have time to re-engineer it because I'm missing the formula and I don't want to go looking it up. So
You could fix it and then post it in an announcement as a screenshot.
yeah, that's not a bad idea. So maybe I will do that. All right, let's call it a night. It's 9:47. What I'm going to leave you guys with is I will stop the recording here. Let's stop.